Hi everyone. In this video we're going to discuss about the testing of means of two normal populations. In the previous videos, in the last previous videos, we have discussed the testing of mean of a population, or if mean is a particular value for that population, and we have done a problem based on that theory. Now we are going to consider the means of two normal populations and we are going to test them whether they are equal or not. So our H naught will be mu1 is equal to mu2. Now to test the testing of hypothesis concerning the means of the two populations is considered, where our H naught is mu1 equal to mu2, where mu1 is the mean of the first population and mu2 is the mean of the second population. So for this testing procedure, we have our H naught as mu1 is equal to mu2. We take it to be mu1 equal to mu2. Now, as we have told, we have to test whether the means of the two normal populations are equal or not. Therefore, we have to take two random samples, because based on the random samples or based on these samples is how we are going to come to an inference. So, we have to take two random samples of size say n1 and n2. This n1 and n2 could be same. Either it could be a same number or it can be different numbers too. So, two random samples of sizes n1 and n2 are taken from the two normal populations. So, corresponding to the normal population with the mean mu1 and mu2 respectively, and sigma 1 and sigma 2 respectively for these two populations. So, based on the samples that we have chosen, based on these random samples, we can compute their sample means. So, the sample means are denoted by x1 bar and x2 bar. We know in this testing procedure, we have to decide, or we have to take a decision based on the sample about this population. We have to take a decision about the population, but based on the sample alone. So, we have to take, or we have to reach to an inference based on the sample we have taken. So, therefore, this x1 bar and x2 bar plays a very important role. Similarly, S1 and S2 be the sample standard deviations. That is, these sample standard deviations are those calculated from the sample. So now we have to frame the test. So for that, we will have to frame the hypothesis in the beginning. So first and foremost, we have H naught as mu1 equal to mu2. Now we have three cases for the alternative hypothesis. That is, either this H1 could be mu1 greater than mu2, or it could be mu1 less than mu2, or it could be mu1 not equal to mu2. So these three cases arise in this testing procedure. So the first case, that is when this standard deviations, the corresponding population standard deviations are known and unknown are the two cases that arise. So the first one is case 1 where sigma 1 and sigma 2 are known. So this is comparatively a simpler case. Therefore, if we know the standard deviation, we don't have to compute it from the sample. So we just have to compute the sample mean. So the test statistic is as follows, where z is equal to x1 bar minus x2 bar divided by root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. And this is said to follow a standard normal distribution under H naught. Similarly, if sigma 1 and sigma 2 are unknown, how will it be? If sigma 1 and sigma 2 are unknown, what we are going to find is, we are going to find the sample standard deviation. That is, sample standard deviation or sample variance. So if we have to find the sample variance, so we have to find the variance using this sample, and we shall replace it in case of the population standard deviation or population variance. So that is the test statistic. So the test is in the test statistic that sigma 1 square is replaced by S1 square and sigma 2 square is replaced by S2 square. This also follows normal distribution, standard normal distribution when H naught is true. So the test procedure is very much similar to the one of one sample normal distribution or one sample Z test. Here also we take a decision based on how the alternative is. What is the alternative sign? So for the first case where H0 mu1 equal to mu2 versus H1 mu1 greater than mu2, we take a decision. We reject this H0 if Z is greater than Z alpha. So we can compute this left side Z, left side LHS Z using this statistic. Using this statistic we can compute the LHS, and Z alpha value we will get it from the Z table. Similarly, in the second case, H0 mu1 equal to mu2 versus H1 mu1 less than mu2, we reject H0 if Z is less than Z alpha. So, if the calculated value of Z is less than the tabled value, then in that case we reject H0. And in the final case, that is in case of two-sided hypothesis, two-sided alternative hypothesis, we reject H0 if mod Z is greater than or equal to Z alpha by 2. So this is the testing procedure. So the testing procedure is similar for all those tests that we are going to do in this case, but the things changes is the Z statistic changes. So I hope this video was useful. Thank you.